Now, let's now move on and talk about the second part of DB2 application development, which is client-side development. So, in this chart, we're just showing you where we are in the DB2 application development overview. So, we are covering the part for the client-side development. This slide shows different ways in which we access DB2 databases. But in the end, basically you have an API which will transform or convert all your instructions into SQL, and that's what DB2 understands. We talk about application development freedom when we talk about coding. Applications for DB2, because all of these languages and more are supported when you work with DB2 as your database. So let's move on and talk about Embed SQL. Embed SQL applications are applications where SQL is embedded into a host language such as C, C++, or COBOL. The Embed SQL application can include static or dynamic SQL, which we will talk more about in the next few slides. In the figure, the C program Hello SQC contains Embed SQL. The Embed SQL API for the C language uses exec SQL highlighted in the figure as a delimiter to allow the precompiler that comes with DB2 to identity the SQL statements to be translated versus the actual C code. You may also note in the Hello SQC listing that some variables are prefixed with a colon, as in DB name, user ID, and PSW. These are called host variables. Host variables are variables from the host language that are referenced in the Embed SQL. Statements issuing the precompile command, also known as the prep command, with the bind file option that generates two files, the hello being the bind file containing only SQL statements, and the hello C file containing only C code. The bind file will be compiled using the bind command to obtain a package that is stored in a database. A package includes the compiled executable SQL, and the access path DB2 will follow to retrieve the data. To issue the bind command, a connection to database must exist in the bottom of the figure. The hello file is compiled and linked like any regular C program. The resulting executable file hello has to match the package stored in a database to successfully execute. Let's now talk about static SQL and dynamic SQL. Static SQL statements are the ones where the SQL structure is fully known at precompile time. So for example, we have select last name salary from employee. We know beforehand that we want the columns last name and salary, and we want to get them from the table employee, and this is known as precompile time. Before the program is run. So this is static SQL. Then we have another example where we have a select last name salary from employee where first name equals F name. F name is a host variable, and even though you don't know the value of this variable beforehand, still this is considered static SQL. So though the value of the host variable is known, until runtime, its data type is known from the program, and all the other objects, column names, table names are fully known ahead of time. DB2 software uses estimates for this host variables to calculate the access plan ahead of time. Therefore, as said before, this case is still considered static SQL. You precompile, bind, and compile statically executed SQL statements before you run your application. Static SQL is best used on databases whose statistics do not change a great deal. Now let's take a look at dynamic SQL. In this example, the names for the columns and table referenced by the statement are not known until runtime. Therefore, the access plan is calculated only at runtime, and using the statistics available at that time, these types of statements are considered dynamic SQL statements. Some programming APIs like JDBC and ODBC always use dynamic SQL regardless of whether the SQL statement includes known objects or not. For example, the statement select last name salary from employee has all the columns and table names known ahead of time, but through JDBC or ODBC you do not compile the statements. All the access plans for the statements are calculated at runtime. In general, two statements are used to treat a SQL statement as dynamic. Prepare this statement prepares or compiles the SQL statement. Calculating the access plan to use to retrieve the data. Execute this statement executes the SQL. Alternatively, you can execute a prepare and execute in one. Single statement using execute immediately. So in the first example, we provide a select statement that we want to execute. The same thing with the other execute. Immediately in case 1, but this time we have a different value for department. In the first one, department was equals 1. In the second one, department equals 2. So for DB2 will take each statement and consider each of them as different statements. Therefore, DB2 in this particular example would be calculating the access plan for the first one and then executing it. The same thing for the other one. It will calculate the access plan and then execute it. On case number 2, we have that we are going to execute also the select name from where department equals, and then we put a parameter marker. So what this means is that in this case we can run a prepare statement where we are basically compiling these select statements, and then we can use the execute statement to execute the same statement several times but using different parameters. So in the first one we use 1 and in the second one we use 2. So this method is better when you plan to execute the same statement several times but using different values for the parameters. Now, as mentioned earlier, Embed SQL applications support both static and dynamic SQL. Some people get confused and they only one thing that Embed SQL works with static SQL, but that's not really the case. So example, have a static SQL in a Embed C program, and in the example at the bottom is an example of a dynamic SQL in Embed C program. Let's move on and talk very briefly about ODBC and CLI. So CLI stands for call level interface. DB2 CLI conforms to ODBC 3.51 and can be used as the ODBC driver when loaded by an ODBC driver manager. The figure can help you picture DB2 CLI support for ODBC when you need to run a CLI or ODBC application. All you need is a DB2 CLI driver, which is included in any of these: the IBM Data Server Client, the IBM Data Server Runtime Client, and the IBM Data Server. Driver for ODBC and CLI. To develop a CLI ODBC application, you need the DB2 CLI driver and also the appropriate libraries. So this could be found only on the IBM Data Server Client. Now, ODBC CLI is very popular mainly because the code is easily portable between several RDBMS vendors, and unlike Embed SQL, there is no need for precompiler. Said before, it runs only dynamic SQL. Now let's talk about JDBC, SQL J and PERC query. JDBC stands for Java Database Connectivity, and it's a Java programming API that standardizes the means to work and access databases. In JDBC, the code is easily portable between several RDBMS vendors. The only changes required to the code are normally which the JDBC driver to load, and the connection string JDBC uses only dynamic SQL and it is very popular. SQL J, on the other hand, is the standard for Embed SQL. In Java programs, it is mainly used with static SQL, though it can interoperate with JDBC. Normally, it is more compact than JDBC programs and provides better performance. However, it is not widely accepted. SQL J programs must be run through a preprocessor, which is called the SQL J translator, before they can be compiled. Pure Query is an IBM Eclipse based plug-in to manage relational data as objects. Available since 2000, Pure Query can automatically generate the code to establish an object. Relational mapping, ORM, between your object-oriented code and the relational database objects. You start by creating a Java project with Optim Development Studio ODS connect to a DB2 database, and then have ODS discover all the database objects through the ODS GUI. You can pick a table and then choose to generate the Pure Query code, which will transform any of the underlying relational tables entities into a Java object. Code is generated to create the relevant SQL statement and parent Java objects that encapsulate those statements. The generated Java objects and the contained SQL statements can be further customized with Pure Query. You can decide at runtime whether you want to run your SQL in static or dynamic mode. Pure Query supports both Java and .NET. Though there are several types of JDBC drivers such as type 1, 2, 3, and 4, type 1 and 3 are not commonly. Support of these types has been deprecated. For type 2, there are two drivers as we will describe shortly, but one of them is also deprecated. Type 2 and Type 4 are supported with DB2 software as shown in the table. Type 2 drivers need to have a DB2 client installed, as the driver uses it to establish communication to the database. Type 4 is a pure Java client, so there is no need for a DB2 client, but the driver must be installed on the machine where the JDBC, as mentioned earlier and shown also in the table. Type 2 is provided with two different drivers. However, the DB2 JDBC Type 2 driver for Linux, Unix, and Windows, while file name deprecated when you install a DB2 server, a DB2 client, or the IBM Data Server driver for JDBC and SQL J, the DB2.jar and SQL zip. For files compliant with JDBC 3.0 are automatically added to your class path. This concludes this presentation. Thank you for watching.